Just to give you a free demo that what I will be doing on the demo. So this coverage.cpp is the program which contains uh, which which I have to test actually to see that my script is working properly or not. This test dot cases is the script which I will be using to generate random cases uh, for my program. As you can see here the that I have used two conditions here. First is Gauss and second one is normal random. So I have used Gauss here because there are some program in which is the input very close to 0 is required. So I have so to fulfill that condition I have used this thing. uh, these two will give random values very close to 0, so that will give all sorts of input to my program and thus give me a sense of like safety that my program is going through all sorts of input from 0 to infinity, the maximum integer range. Okay, so this was about test cases.py. In the generate.sh I am just inputting from user the number of test cases which I have to generate, and then I will store that number of test cases in the file test.txt. If you would like to see that test.txt, it is actually this is a file. It contains 10 lakh 10 cases here. As you can see, the number of test cases is 10 lakhs. So I will use my reduce script to bring it under 50 or 100, whatever, depending on the program. So so this was about generate script. It's a basic program to it is a basically a vapid script to call my Python script which will fill my test.txt. So after this I have this reduce.txt. Okay, so this reduce.txt is taking that is actually calling a function, actually calling a script called scm.py. This script contains the code to reduce the number of test cases depending upon a variable m. Variable m is the number of centroids which I will be initializing with 2 and will increase it twice every iteration. So what is actually happening here is this is the reduce, this is the FCM, this is fuzzy c means algorithm. This is the heart of reduce script here. Actually I am importing it from a SCM library of the Python. So and importing numpy. This importing OS and os.environment is not required here. It is only useful if you have a GPU and you want to fasten your calculations. So I am loading my text.txt in a variable x, then I am initializing my FCN construct STM model with the number of cluster as n, which I will give as an input from my which I will give as an input from my that thing that reduce the sh script, and then I will fit this model. Then I will store the centers of the model, which actually contains the centroid of the partition which I have created in this variable, and then I am storing this number of variables in a result.txt file. So and these three lines are the basically for taking input from the user. So now going forward to the reducer sh file. This in this file first I have initialize m equal to 2. So when I do this, then this will partition my 10 lakhs test cases into two sets, each set which will have a one centroid, and I will choose those two centroid as my reduce test case and test the coverage of my program using the gcov tool. As you can see here, I am iterating over wide read line. This thing iterates over this file which I have created over in this step. So I am giving it as an input to this dot coverage binary file, and then I am checking its coverage through gcov tool. As we know that gcov dot minus dash b dash c dot coverage will give those 4 lines which contain the information about the branch coverage, code coverage, conditional coverage, and all sorts of things. So I am extracting specifically the branches, then the percentage of those branches, and I'm storing this in a new.txt file. This I'm doing this because it would be very useful to it will be very beautiful to see the process happening in front of our eyes in a file format. So I will show you once I've done explaining. So and I'm storing every input in this reduced test cases.txt in case if my input if I get the desired number branch coverage, and I will exit through break 2. This condition is when we have a coverage of greater than 95 we have achieved, then I will break it off, because I can improve this thing, and I will do that in the coming time. So this is just initial guess. So and this thing actually exit when the coverage is greater than 95, and just print the rest, which the reduced number of test cases which we achieve here. I have chosen 95 here because there may be a cases when there may be a cases when the number of what I wanted to say that there may be a cases when we are increasing the number of test cases, but the branch coverage is not increasing anymore. So to tackle that case, I have chosen a value less than 100 to like this is the condition to tackle that case. It will see if the branch coverage is just stagnant, then I will exit easily here and print my number of test cases and coverage, and then here I am coming out of the this is important rm coverage, or I am removing this file because removing this file will reset the gcop tool to the 0 for the next iteration, which I will do in the next step. To do that thing, I am removing this file again and again, and at the end I am giving null value to my redo test cases.txt if I am not able to exit this thing. Okay, then I am beautifully printing all the result here, and then this is it. To show you the result, this is the number of test cases which I have got after implementing reduce the SSH from those 10 lakh test cases, like 99.999% reduction here, because this is the small program. So I know this is seeming unbelievable results, but I have to test it on a big program to see what it would do on this. This is that intermediate file to call this thing. New.txt was also intermediate. It will get filled after I run this script. Okay, so now let's run the script. Gets into we are currently inside the we are currently inside the folder which contains my assignment. These are the files there. So first of all, I will call bash generate.sh, and I will give 10 lakhs as the input. Okay, 10 lakhs. Okay, this will generate our test.txt with 10 lakhs input. Okay, then I will call reduce script directly. So bash reduce dot sh. Okay, this will directly do my thing. Oh, what I have done something errorless here. Generate dot ssh. Okay, I have actually changed that program. Let's suspend for a minute. Coverage.cpp. I have actually I have actually these 3 lines I have written just like that while making the video. So now I run this thing. So we see that this file just generated .gcop file. This will be the file which will keep track of those the branch coverage as we will see for different inputs. So in the first case, we saw that they were m equal to 2. I have chosen 2 subsets, so we will get 2 centroid, and for those 2 centroid we are getting a coverage of 58%. So now as the coverage is very less, so I will increment my m by a factor of 2. Then we will have 4 test cases. Then we will do the same steps on those 4 test cases, and we will see that after running those 4 test cases we will get the coverage which we will get the 100% coverage, so it exits basically. As you can see this line, this line actually, this is the file new dot text as new dot text. Oh, actually I'm emptying it at the end, so that's why it's not showing there. Generate reducer sh actually this thing, I'm catting this file and then I'm making nulls, that's why it's not showing. This file contains the, for the first case, then when we have two test cases, these were the coverage percentage, and when 4 test cases, this was the coverage percentage for each subsequent test case after. So the reduced number of test cases are 4 and the printing test cases is this. So thank you, this was my reduce script.